Note 6.1, Part 1, Verifying a Solution. The objective of this lesson is to determine if a point is a solution to a linear equation by graphing the line and point, establishing if the point is on the line, and by verifying that the ordered pair xy makes the equation true. So to start off, a few ground rules. An equation is true for an ordered pair xy if, when the values of x and y are substituted into the equation, both sides of the resulting equation are equal. An equation is false for an ordered pair xy if the values of x and y are substituted into the equation, the sides of the resulting equation are unequal. A point is a solution to an equation if the ordered pair makes the equation true. The point will be on the line when it's graphed. A point is not a solution to an equation if the ordered pair xy makes the equation false. The point will not be on the line when graphed. Example 1. Determine if the point 2, 3 is a solution to the equation y equals 2x minus 1. You must first graph the line. So this is in slope-intercept form, so we begin at the y-intercept of -1, and we move it with a slope of 2 over 1. So that means up 2 to the right 1, up 2 to the right 1. Or if you wanted to get fancy, you could go down 2 to the left 1. Make sure you use a straight edge when you're drawing your line. Now, to determine if the point is on the line, graph the point 2, 3. Remember, when we're graphing coordinate points, we do x then y. So we do x, 2, and then 3 in the y direction. Visually, the point looks like it is on the line. So the point 2, 3 is on the line. Now, algebraically, we can prove whether it is on the line or not. So we take the equation y equals 2x minus 1 and the point 2, 3, and we substitute in the x and y respectively. So y is 3, 2 times 2 minus 1. Simplify the expression, and 3 is equal to 3. This is a true statement. So therefore, we have verified it by graphing and by substituting the point into the equation, so we have determined that the point 2, 3 is a solution to the equation y equals 2x minus 1. Oh yes, the point 2, 3 makes the equation true. Now in example 2, we're going to determine if the point 4, -1 is a solution to the equation y equals -1/2 x plus 3. So graph the line first. We begin at 3 on the y-axis, and our slope is -1/2, which means that we would go down 1 to the right 2, down 1 to the right 2, or if you wanted to be fancy, up 1 to the left 2. Draw your line. Now graph the point 4, -1. We start at the origin, do 4 in the x direction, and -1 in the y direction. Visibly, this point is not on the line. So we have to do the diagnostic test before we determine for sure whether this is a solution or not. So taking the equation y equals -1/2 x plus 3, we substitute the point 4, -1 in for x and y respectively. -1 is equal to -1/2 times 4 plus 3. So -1 is equal to -1/2 of 4 is -2. -2 plus 3 is +1. This is not true. So this point 4, -1 makes the equation false. The point 4, 1 is not a solution to the equation. Graphically, it's not on the line, and it made the equation false when substituted in. Please do the examples on the back before proceeding.